here's what we're going to do today. We're going to go very, very, very fast. I apologize for that. All you really need to do is be able to recognize these pictures. We're going to graph tan x, cotan x, cotangent, secant, and cosecant. So break out your calculators. Okay? We're going to draw on our paper. Just do me a favor. Draw a graph. Give me a little room up and down. 2 units and across this way. We're going to cut it off at 360 on this side and negative 360, but it would keep repeating over and over again. Up and down doesn't matter for the tan graph. So we're going to break it out. So this is negative 180, negative 90, negative 270, 90, 180, 270. Okay, there you go. Okay. So here we go. We're gonna throw this in the calculator. Please turn your calculators on. Turn your calculators on. Make sure it's in degree mode. Make sure the window is set to being negative 360 to 360. Okay, and then hit the graph button. Whoops, that's the wrong graph. We're gonna type in the tangent of x, and I like it when my graphs are bolded.
Wait, what was the window?
Look, take a look. What is the window? The window is written down on your paper, right? The window is written down on your paper. I know people keep always asking about that. Think about it. You are trying to get this picture in your calculator. So it's got to go from negative 360 to 360, scaling it by 90. The y-axis, I didn't list anything down because I'm telling you point blank it doesn't matter. So here's a picture of the tangent graph. It looks kind of like a heartbeat. These points right here are called asymptotes. That's okay. In some of the new calculators, my calculator graphs the asymptotes, and yours might not. Okay? So here's what we're going to do. What I want you to do is I want you to draw in those lines. There you go. I want you to draw in the lines. I want you to draw in the lines and graph them up. And that's what I want you to draw on your sheet. That's it. So here we go. So each one of these hash markers written down is an asymptote. And this is what the tan graph looks like. This is not a short answer question. Don't worry about drawing the graph. It's multiple choice. By multiple choice, I mean I will say which one of the graphs best looks like a tan x tangent graph, and you will have to choose from this one versus the other 3 I'm going to draw on the board. Whoops. Now we're going to do the cotangent graph. But we're going to run into a problem. What's the problem? Anybody know? One over tan. Yeah, there literally is no cotan button in your calculator. So in order to graph it, you have to graph it in its reciprocal form. So now we're going to draw the same type of scale that we had before, right? We got some business going on up and down. We've got some other business going on left and right. Whoops. I'm not going to put that marker right there. We're going to go 360 to negative 360, scaling it negative 180, negative 90, negative 270, 90, 270. There you go. And once again, we're going to use our calculators to do this. There is no way I'm asking you to remember this. 1 divided by the tangent of x. And you can see that the tangent and cotangent are very much related. They look like the same graphs, and that's why using your calculator to be able to identify the difference is super important. The asymptotes are in different spots. Let's see. The asymptotes are at, let me go back to, oh, good, thanks. Yep. It's like every interval of 180 degrees, right? Good. And then so the tangent graph, the cotangent graph itself is kind of going in the opposite direction as the tan graph. There you go. That's what it would look like. So look, take a look. Tangent graph versus cotangent graph. The one last thing that I want to put in is the fact that these marks right here are the what? Yeah, they're the asymptotes. They're the values for which the function might be undefined. So like also in a multiple choice type question, right? If I don't ask you to pick out a graph, I say to you, okay, so in the cotangent graph, what value for cotangent it makes the graph, is the graph undefined at? And you could say negative 360, you could say negative 180, you could say 0, you could say 180, or you could say 360. That's the point at which it's, you know, there would be a denominator of 0 and it wouldn't work. All right, so what's up next? Secant or cosecant? Y equal, there's no secant button. There's no secant button. How do you graph that? 1 over, no two cos go together. No two cos go together. I'll explain what this graph is. For this graph, you will need some room going up and down. So let's do 360. Once again, we're graphing it from negative 360 to 360, scaling it by 90. Right. Whoops. There. Okay. That's horrible. I can't have that bad. Okay, and this one is actually difficult to graph. Very difficult to graph. Let me show you why. So the secant is very much related to the cosine graph. Let's take a look at the picture of it before we try and put it in. 1 divided by the cosine of x. Let's take a look. Somebody in period 1 said it looks like two people holding hands. Kinda. Okay. So how do you draw these in exactly? Like where does that curvy part stop? Here's how you do that. The normal cosine graph, the normal, whoops. Let me put it up over here at 1. I apologize for that. The normal cosine graph goes up and down, has an amplitude of 1. Let's give it its normal markings. All right. Basically, we're going to create the shadow of a cosine graph. Now, there's the shadow of a cosine graph. That's the first step towards drawing this. The second step that you have to do, if you wanted to draw it out, but it's highly unlikely, is let's draw in the asymptotes. Where are the asymptotes occurring? Nope, there's not one at 360. Very nice. Yeah, the asymptotes are occurring right here. And so now here's how you draw it in. This bottom part of the normal shadow of the cosine graph is where the secant graph begins. And that's how you form this U shape. And it's contained within the asymptotes. You can think of asymptotes almost like barriers. They can't be breached. And so that picture in black is the secant graph. Now let's take a look at what a multiple choice question would look like. So if these are the multiple choice answers, and I said, oh, could you like pick out the secant graph for me? Do you think you could do it using your calculators? Good. That's pretty much the extent to which it's axed. it's asked. We got one more to do and then we're done and you're free. Free. Okay, these are the asymptotes. These are the asymptotes. All right, whoops, let's go big screen. Number 4, what's the last graph we have to do? Y equals the cosecant of x. There's no cosecant button, so what are we graphing? Very nice, and it's going to do the same, we're going to do it the exact same way that we did the secant graph. We're going to need lots of room going up and down. Whoa. We're going from negative 360 to 360. Okay. Let me give you an idea of what it looks like. Remember yesterday we talked about how sine and cosine are intimately related. In fact, secant and cosecant are going to look very much alike. They're going to be just shifts of each other. So, we draw in the sine graph, the shadow of it, to give us the markings for where the cosecant graph is going to come in. Over there. Real fast. Once again, I apologize for how fast we have to go. Yep. There's our sine graph. That's the shadow. We drew that in so we know where that point, that point, that point, and that point would be. Now we got to draw in the asymptotes. Well, they're occurring every 90 degrees, every 180, right? Starting right there. Starting right there. And then once you have those drawn in, you just draw in this U-shaped curve, and that's going to be the cosecant. It would just repeat on forever. Suppose you went off to 720, you'd see it repeating over and over and over again. One last thing to do. What's up? I know, just finishing it up, and then we're done. We're going to review for our test tomorrow. Just want you to know that these graphs, these lines drawn in red are the asymptotes. Yep, those guys right there. Barriers, lines which the graph itself cannot cross.